Hey everyone, I hope you're doing well today. In this video, let's talk about two-dimensional or 2D geometry. Specifically, we're going to start off by talking about shapes and look at the differences between polygons and non-polygons. What differentiates polygons from non-polygons is that they always have 3 or more sides, their sides are always straight, and they're always going to be closed shapes. If a shape doesn't meet all 3 of these requirements, then it's not a polygon. Let's talk a little bit about the most popular types of polygons that you'll encounter. Starting with the polygon with the least amount of sides, triangles have 3 sides and they move up from here. Typically, once you get past 10 sides, you don't have to worry too much about the names of them, but you can also remember 11-gon as a hendecagon and 13-gon as a tridecagon. Don't worry too much about those names though, because typically people are going to call them as an 11-gon or 13-gon, 14-gon, and so on and so forth. And while there's tons of different types of polygons that we could talk about, today we're going to focus on triangles and quadrilaterals. Let's talk a little bit more about triangles now. So it's important to know that we typically classify triangles either by their sides or by their angles. If we have a triangle that has 3 sides that are the same length or they're congruent, this is called an equilateral triangle. They have 3 congruent sides. That's what the symbol means. If, however, we have a triangle that has 2 congruent sides, but one side is different, this is called an isosceles triangle, so it has 2 congruent sides. A third way we can classify triangles by their side lengths is that if all 3 sides are different lengths or none of them are congruent, this is called a scalene triangle. With these types of triangles, none of the sides are congruent to each other. Besides classifying triangles by their side lengths, we can also classify them by their angles. If you see a triangle and all 3 of the angles are less than 90 degrees, then this is called an acute triangle. In another scenario, if you find a triangle that has one angle that's bigger than 90 degrees or greater than 90 degrees, this is called an obtuse triangle. And in a third instance, if you see a triangle that has a 90-degree angle or a right angle, we call this a right triangle. So by sides, we can classify triangles as equilateral, isosceles, or scalene, and by angles, we can classify triangles as acute, obtuse, or right. And not only can you classify a triangle by its side lengths or its angles, but you can also do both for each triangle that you see. For example, if you were to look at this triangle here, because all 3 of the side lengths are different, we know that this is a scalene triangle. And if we look at their angle measures of 32 degrees, 89 degrees, and 59 degrees, since they're all less than 90 degrees, this is an acute triangle. Therefore, we can just call this a scalene acute triangle or an acute scalene triangle. What about this triangle? We have 2 side lengths of 8 and 8, and we have a third side length of 8 times the square root of 2, so this is an isosceles triangle since 2 of the side lengths are congruent or equal to each other. Looking at the angle measures here, we see that we do have a 90 degree or a right angle, which means this is going to be a right triangle. Classifying this triangle by side lengths and angles, we can say that this is either an isosceles right triangle or a right isosceles triangle. Here's one more example. Looking at the side lengths, because they're all different, we can say that this is a scalene triangle, and looking at the angle measures, since one of them is greater than 90 degrees, we have this 138 degrees, we know that this is an obtuse triangle. Naming this triangle very specifically, this is a scalene obtuse triangle. Basically, we can just give these triangles nicknames based on how their side lengths look and how their angle measures look. Now let's take a peek at some different types of quadrilaterals or 4-sided polygons. In the world of quadrilaterals, we have these first types of shapes called kites. Here's a drawing of a kite, and you can see that the top 2 adjacent sides are the same length and the bottom 2 adjacent sides are also the same length. We're not really going to talk about kites in this video, but just know that they have 0 pairs of parallel lines. In addition to kites, another quadrilateral that we'll talk about are trapezoids. These little arrows that are drawn here just represent that the top line and bottom line are parallel to each other. The unique thing you want to know about trapezoids is the fact that they have exactly 1 pair of parallel lines. And a third type of quadrilateral we'll talk about are these things called parallelograms. The unique thing about parallelograms is that the opposite sides, like the top and the bottom here, are parallel to each other, and the opposite sides on the left and right, or these diagonals, are also parallel to each other. Parallelograms have 2 pairs of parallel lines. Now let's look at some more specific types of parallelograms. A common parallelogram that you've probably seen a lot are these things called rectangles. Of course, rectangles have two pairs of parallel lines since it is also a parallelogram, but what's unique about them is the fact that they have 4 right angles, or 4 angles that are 90 degrees each. Another unique type of parallelogram is a shape called a rhombus, or rhombi for plural. Of course, rhombi have 2 pairs of parallel lines just like the rectangles, but what makes them a little bit different from rectangles is the fact that all 4 of the sides are congruent, or are the same length. While rectangles and rhombi are the 2 types of parallelograms that we'll talk about, rectangles have 4 right angles, which makes them special, and rhombi have 4 congruent sides, or 4 equal side lengths. Now, if you're wondering where the square comes into play, that's where we're headed next. Arguably, the square is the most picky quadrilateral out there. Not only is a square a parallelogram, but it is also a rectangle and a rhombus. For a polygon to be a square, it has to have 4 sides, 2 pairs of parallel lines, 4 right angles or 4 90-degree angles, and 4 congruent side lengths or 4 equal side lengths. If a polygon meets all of these requirements, then only then does it get to be a square. Basically, here's our family tree of quadrilaterals that are important to know. If it helps, you can think of this as sort of a family tree for all the quadrilaterals that we'll need to know. And that wraps up this video on an introduction to 2D geometry, mainly focusing on triangles and quadrilaterals. Stay tuned for the next few videos that are going to come out that are going to be about finding the area of quadrilaterals, finding the area of triangles, as well as applying these to coordinate planes and some composite figures, and then we'll go into some 3D geometry talking about volume and surface area. As always, keep up the great work, and I'll see you in the next one.